Today, class, we're going to be talking about and learning about inertia. First, let's go ahead and define what inertia actually is. So inertia is the object's tendency to resist changes in motion. But rather than just say changes in motion, we're going to look at it in terms of velocity as that motion. And changes in velocity with respect to time is really how we have defined acceleration. So a better way that we really want to identify and define the inertia of an object is that object's ability to resist acceleration. So when we look at the ability to resist acceleration, what that really says is that it really wants to maintain the state of motion that it's in. And this ties with Newton's first law, which we'll talk about in a second. But really, what does that really mean? Well, the larger the inertia of an object, the more resistance to change its state of motion, to resist accelerations. For example, when you look at this bowling ball here, right? It's actually at rest right now, so it wants to maintain its state of rest. Without acting on it by an external force, which is really what Newton's first law is that it's going to stay at this point of rest. However, once this bowling ball starts to get rolling, it wants to continue to roll. That's the nature of inertia, is that whatever it's doing, it wants to continue to do so unless it has to actually be acted upon by a net external force. If I look at this soccer ball, it actually has much less inertia than this bowling ball, and it's a lot easier to actually get it to start moving. However, it still wants to stay at rest, but therefore, because it has less inertia, it takes less effort or less force to get it to start to move. Really what we're talking about here in terms of the differences between the bowling ball and the soccer ball is really its mass. So let's define mass. And mass, most likely what comes to your mind when I ask you for a definition of mass, is going to be the amount of matter that an object has. And while that's true, it doesn't really tie together with how we're really pinning down mass in relationship to what we're understanding with relationship to inertia. So inertia and mass are really synonymous, and the way that we're going to define mass is it's really the measure of the amount of inertia that an object has. So mass is going to be the immeasurable amount of inertia that an object has. That's how we're going to define the mass of an object. And the base SI units for mass we're going to use as kilograms. So be careful if an object's given to you in grams. We want to always get back to that base SI unit of kilograms for mass. So if mass is the measurable amount of inertia that an object has, the more mass it has, the more inertia it has, so therefore the greater tendency to resist changes in motion. So another way to think about this would be like, a toy truck or a Mack truck, right? The toy truck, it doesn't take a lot of effort to get it to start moving. Whereas the Mack truck is significantly more mass and therefore more inertia, and it takes significantly more force to get it to start moving. Well, the same is really true here with this bowling ball and the soccer ball. But first, let's go ahead and define what Newton's first law really says. Okay, so you may be familiar with Newton's first law probably from middle school, and really you probably heard this or may have heard this referred to as an object in motion stays in motion and an object at rest stays at rest. But it goes a little bit deeper than that, okay? Newton's first law is referred to as the law of inertia. And it states that an object at rest stays at rest and an object in motion maintains a constant velocity, both speed and direction, unless acted upon by a net external force. Now there's some things in here that we need to define, getting to forces. that we will continue that on as we move into Newton's second law. We'll break that down a little bit further, but for right now, just understand that it's an external force that's acting outside of the object's system, okay? So in other words, these objects here maintain their state of rest. Both are at rest unless something comes along and actually works on it or forces the object to change its state of motion. So inertia is telling us that the bowling ball has a greater mass and a greater inertial mass, a greater mass that's going to have a greater resistance to want to change or accelerate, change its motion. So it has a greater resistance to acceleration. Well, let's look at this little cart here. It's a smart cart that we'll be using in more lessons to come. But I'm going to actually just use the plunger. There's a spring-loaded plunger here that has a certain amount of spring force. So we can apply a constant force to both this soccer ball and this bowling ball and see if we have any differences in the rate at which it accelerates. So here we'll first start with the soccer ball. Okay, so we can see and observe that change in motion. Let's go ahead and do the same thing for the bowling ball. First, let's get it at rest. Clearly there's a difference. Same exact force. In fact, I had to brace myself because the kickback from the bowling ball was actually trying to move me. Because it has so much inertia, it has such a greater resistance to want to accelerate or change its state of motion. Let's also look at this steel ball here. We have a steel ball that's maintaining a constant velocity on your right, and another steel ball that is at rest. And both want to maintain their state of motion. They want to maintain a constant velocity for the ball, that steel ball that's rolling, and the other one is at rest, and the steel ball will remain at rest. Both of these objects want to continue in their state of motion unless acted upon by a net external force. And as you can see here, at the end of the track, the steel ball that was moving at a constant velocity doesn't change its state of motion or maintains its constant velocity, both speed and direction, until the block is actually impacted by the steel ball. So the steel ball then experiences an external force that causes it to change its state of motion or causes it to accelerate. In this case, causing it to stop moving with the constant speed and direction. And actually, the steel ball also applies an external force to the block that causes it to change its state of motion. While it was at rest, the steel ball actually applied a force, an external force, to the block, causing it to actually move. In the next lesson, we'll start to talk about Newton's second law, and we'll take a closer look at this relationship between mass, the net external force, and the accelerations that are caused by these interactions. Thank you, and I'll talk to you soon.